Okay, let's talk about the direction of this one first, because that's probably what you have your question about. So the approach of a south pole magnet. So let's draw this south pole magnet, right? Here's the north, here's the south, right? And here's the page. Okay, this south pole magnet is approaching. So what you want to do is you want to repel that south pole magnet, right? Okay, because we're resisting the change in flux. And so what we're going to do is we're going to make a loop here, okay, such that we have the south pole facing up, okay? Now to do that, what you want to do is you want to actually go clockwise in the plane of this page, okay? Now do that, take your right hand, wrap your fingers clockwise. Notice that the butt of your hand now is facing up toward this thing, and that would be a south pole, right? So that's why the current is going to go clockwise, because we're going to make the current flow. As we look down from above, okay, if that magnet, if we could look in this perspective, right, okay, that we're going to see the current go clockwise, and that's going to create a south pole facing upward, okay, north pole facing downward, right? And that's how we repel the magnet, right? So that's the direction of this, right? Is that we always want to repel that magnet, right? And then we know that we want to know what current flows, right? So all we're going to do is use Ohm's law. The current is just simply going to be the EMF, or the voltage, divided by the resistance, right? Okay, so let's find the EMF first, right? Our voltage, or EMF, is going to be NBA. I guess it's just a single loop, right? Okay, so NBA over T, right? And there's one winding. Our area, our change in B is 1.6 minus 0.125, right? And then the area is 0.45 times 0.45. And then our time is 0.026 seconds. Let's see if we can get the right number here. Okay, let's see. Parentheses 1.6 minus 0.125, end parentheses, times 0.45 squared divided by 0.026. And I'm getting that the EMF is 11.48748 volts, right? So the current is going to be 11.488 over 0.85. And that's 13.5 amps. Wow, that's a strong current. Okay. So again, the magnet, basically the strategy here is that whatever current flows in the plane of this, in the plane of the page, right, is going to flow in such a way as to oppose the motion of the magnet. If a south pole approaches, you present it with a south pole to repel it. If a south pole were to recede, well, for a receding south pole, you'd want to draw it back. So you'd present it with a north pole to keep it from moving away from you, right? So anyway, but this one was approaching, so we wanted to repel it, so therefore clockwise. All right, hope that helps.